So first of all, let's say that you have created this 3D model and it's really not an optimized model, but looking at it from far away it looks right for being a sprite. For example, if it's a 128 by 128, it looks fine. You need to render this out from left, right, because he's asymmetrical, front and back, to get all the 4 directions, but you can also do diagonals as well. Having this as a 3D model will save you a lot of time drawing all the sprites and their different animations. Okay, so what do? Before we get this character into our system, you need to select everything on him that needs to be exported and put it in a group. Hit Ctrl G. Let's call this bad guy. Okay, then we save the file, and then we can open our Sprite Render Kit blend file. As you can see, the Sprite Render Kit file is empty, so before doing anything we must first select the first layer. When we are on this layer, click here, then you go to File, Append, and then you navigate to your bad guy, and then inside the blend file look for the group that you just made, group bad guy. So now when we click Append, sometimes you might get this error. This has nothing to do with our system, this is a Blender problem with their depth graph. You just do reward trusted. Okay, yes, and if reward trusted breaks, then you just append the file again and it will roll fine. So after we've appended the file, we can check the animation. It's running all right. So as you can see, the system is not set up. The first thing we need to do is we need to center the sprite so all 4 cameras can render it properly. Select its rig in object mode, and that way you can move it down, but you can also scale it down. So first of all, look at the top 2 cameras, try to get it to fit roughly, and if you as you can see, the left side is a bit offset. So in this right now we're moving it on the Z axis, but we also move him a bit on the Y, so we can level up the left and the right side. And if we move him a bit up, then we'll see that now he's leveled here. Another thing we can do is that as you can see, we imported him on the first layer. Now we can go to the camera controls layer, and I put this on a different layer because I don't want him to get in my way when I select the camera controls. I've actually made a controller which lets you move the bottom 2 cameras. Sometimes when you import the character and you place him, a bit of him might be coming out of the rendering frame, so use this controller to center it roughly like this. And the other nice thing here is that you can actually play the animation and see if during the animation a part of him goes out of the screen. In our case it looks fine, so his silhouette doesn't have to be exactly the same. After we played the animation and test it, we have to make sure that its frame range is correct. So in this case it's 1 to 7. You can set the frame range here. You set the starting frame and the ending frame. They have to correspond to your start and end frame in the original file. Let's look at some of the other controls that we have in this system. This controller controls the height of the cameras. So by using this, you can actually make the camera render him from a higher level. So as you can see, if you prefer to render him, then it will be more of a top-down game, but then you will hide his face during the walk animation. In this case, I will move the cameras down a bit so I can see his face, and leave it like this so it looks like a bit of an evil grin when you're looking from the front. So that's all that this controller does. If you want to move a specific camera up and down, you can absolutely do so by selecting its empty controller. Let's say that we don't like how high the camera is here, so what we will actually do is, here you can see the name of the camera. I can move only this camera a bit like this, so its silhouette is as tall as that. So as you can see, you can move the height of each camera individually, or you can move them all together up and down. The next controller we'll look at is this controller here, right here. This is the global controller. You can move it on 2 axes, and this will simply move whole rig. Most of the time you're not gonna need to do that. Some of the other controls in the Go controller, in its properties, if you had this panel hidden, hit N and it will reveal the panel. The first property is called isometric angle, and what it does is it rotates all of the cameras, see? And if you want this to be a diagonal movement to be rendered out, you would use this controller and set it to 45, for example. This would be great for an isometric game. The next controller is orthographic scale, and what it does is it controls all of the cameras' orthographic scale. Since rendering sprites, most of the time we use an orthographic camera, then you would use this slider here to zoom in and out. This is pretty much the same as scaling your object up and down, but this way you can do it with the cameras. The next option you have is the perspective focal length, and this does absolutely nothing when you're in orthographic camera. But if you're in perspective, if you set this perspective ortho to 0, you would get a perspective camera. So I recommend against this, but sometimes people, they want some perspective distortion. So when you're in perspective mode, that's when some things might break in the rig, because I haven't designed it for perspective. But you still have the option. The perspective focal length control, as you expect, the perspective focal length of the camera, and it's kind of like the orthographic scale option, but for a perspective camera. You can also move these cameras apart if you want to, if you want them to be further away. Right now I've set up the output right here to create the output sprites in a folder called output. That folder is going to be created in the same directory where the Sprite Render Kit is located. You can change the name of each output by clicking on the node and writing here, but please do make sure that you leave these hashtags. Tell Blender to render a 2-digit number. Before rendering anything, you need to run this script. I've created a script specifically for this scene. So in Blender, to render something, not only do you need 4 cameras to render it from 4 different angles, but you also need to create 4 different scenes, and each scene is unique in Blender. You have to, every time you change settings here, Blender is going to make you change them in all of the other scenes. So as you can see, right now my model that I imported is only on the main scene. None of the other scenes the model is present. In order to get this model and all of its settings synchronized on all of the scenes, you have to run the script. And then I go to the scene 2. As you can see, the model has appeared in it, and in the left cam scene as well. In all of the scenes the model has appeared. But not only that, but the script has synchronized its settings. So for example, if I have a freestyle enabled to render outlines on it, freestyle's line sets will also be here. Anything you set in your rendering settings, and every time you change settings in Blender before rendering the sprite sheet, you need to run the script. Run the script, and that way you'll make sure that all of the settings are synchronized. You can make a test render by rendering only a single image, the usual way. See how Blender created this output folder. So in this case, as you can see, the naming is wrong. Left and right need to be swapped. So I'll click on this node and I'll type right, and I'll click on this node and I'll type left to correct it. After this test render, and after we're happy with all of the settings, we corrected the naming, delete what's in the output folder and render out the complete animation by clicking here. And you don't have to always use Blender Render. If you're a bigger fan of cycles, you can use cycles as well. In fact, you can even use OpenGL to render them out faster. Now that we corrected the naming conventions, you can see that left is properly named and right and up and down, they're all properly named. See how it's creating all the sprites. This saves so much time. Imagine if you had to draw each direction manually. It's so much easier to just quickly make a model. It doesn't even have to be optimized for a game. You can make any model with any topology. If you get decent frame rate and you're able to animate it, then it's very easy to export it with this system to a sprite. See? It works. This is the result. If you go to the other scenes, you see that result. But if you need to tweak any of the rendering settings or your line sets, please don't do it here. Always configure your rendering in the main scene that is on the top of the list, and always run this script before rendering. In fact, I added a line, one last line in the script. If you uncomment this line, what it's going to do is it is going to use the script to render. After it synchronizes everything, the script will render the scene for you, so you don't have to click render here. You can just run the script and it will render instead of the button. Let's re-render this whole scene, but this time we're not going to use the render button. Instead, we're going to use my script to do it. I'll just run the script and it will start rendering again after synchronizing the settings, after updating the freestyle line cover for each of the 4 scenes. And we're ready. Blender is done rendering them. And this time, as you can see, they have an updated core of the outside line. And what you can do from here on is just put them in your game engine. You can use freeware software like Shoebox or another add-on for Blender that will combine all of these images into a single sprite sheet. But most game engines can take an image sequence as well. I've tested out this system on a number of game jams, and it really helped out my team tremendously throughout the years. This is very useful setup. I hope you like it, and if you have any questions or you have suggestions for me, please feel free to contact me on my email address. You will find it somewhere in the comments here in this script. So thank you for watching, and see you next time.